In this lesson, we'll be discussing how to find the range of a logarithmic function using algebraic method. For example, if you are given that f of x is equal uh, x plus 2 all over x minus 1, and you are asked to find the range. Remember, range is the set of y values for which a function can be defined. All right, if we go ahead to solve this in terms of y, we are going to have that our y is equal ln x plus 2 all over x minus 1. All right, we remember the inverse function of a natural log is e to the power of x or exponential of x, meaning for instance, if we have that our ln a is equal b, this will imply that our exponential of b is equal a. All right, if we apply the same logic here, we are going to have that our exponential of y, e to the power of y, will give us x plus 2 all over x minus 1. How do we solve? From here we can cross multiply, right? And we are going to have e to the power of y multiply the denominator, so we are going to have e to the power of y in x minus 1 equal x plus 2. Now, if we go further to expand that the left-hand side of the function, we are going to have that our e to the power of y multiply x will give us e to the power of yx minus e to the power of y multiply minus 1 will give us minus e to the power of y equal x plus 2. Now we see that x is here. On both sides of the equation, we can collect like terms so that we have e to the power of yx, and this crosses over to the other side of the equation. We are going to have minus x will give us equal, right? We have now e to the power of y crosses over here again. It becomes positive. So we're going to have e to the power of y plus 2. Now s is common here. We can factor that out. So we have x in e to the power of y minus 1, because x multiply e to the power of 1 will give us e to the power of yx, and x multiply minus 1 will give us minus x, so that is sorted, equal e to the power of y plus 2. With c here, we can separate e to the power of y minus 1 from x. We make x the focus here. We are going to have e to the power of y plus 2 all over e to the power of y minus 1. We can see that the restriction applies. You cannot divide by 0. That is one of the restrictions, meaning that e to the power of y, so this we imply that our e to the power of y minus 1 cannot equal 0. And for that, to happen, we need to have that our y must not equal 0, because if our y equals 0, we are going to have e raised to power 0 minus 1, which will be e raised to power 0 is 1, which is 1 minus 1, which will give us 0. So you see, y cannot be 0, meaning that this function is defined for all y except y equal 0. Now we have the set of y values, which is that y is a set of all real numbers. Now we can write our range now that y is a set of all real numbers. All right, but y cannot equal 0. All right, this is set notation. Now we can write it in interval notation. Set of all real numbers begin from negative infinity to positive infinity. So we have that from negative infinity to 0, right? Union 0 to positive infinity. All right, because 0 is not included, that's why we are using the parentheses. All right. Okay, this is the final answer.